Let's go over worksheet 1.5, Compound Inequalities for my class. This is a worksheet that I gave them. Let's just go over it. Okay. Number one, I want to write the inequality here. So the key thing is that is my x. It looks like we are between -3 and between 4. Now, it is closed circle, so I put the line underneath it, but there we go. X is between -4 and -3. Over here, again, same idea. Your red's your x, that's the spot, and x is between -1 and 6, but no, it's an open circle, so no lines. There we go. Over here, this is an or statement. You have things in an opposite way, so it makes it an or statement. We have x is less than, and remember, if you're not sure, you can always tell it matches this, is less than -4. Open circle, so they'll both can not have a line underneath it. And then over here we have x, it's their x. X is greater than 2. So we have x is less than -4, or x is greater than 2. Same thing over here, we have an or statement again. And this time we have, this is our x. We are less than, we're on the left side of it, so less than 1, -1. And we have x is greater than 5. So right there. These two, we have x is less than or equal to -0.5 and less than 0.25. That was a rough one, but it looks like 0.25. Over here, more decimals. Here's my x, and this one between -1.2 and -0.4. There we go. So that's how you read from a graph. Now let's actually solve it. Now, a lot of times when it's like this, you just solve each one separately, and then we're going to graph it. So let's solve this one first. Here's my line to subtract 5 from both sides. I get 2x is greater than -8, and then we divide by 2. X is greater than -4. And we're going to move on to this one. Subtract 7 from both sides. 4x is less than 8. Then divide by 4. X is less than 2. So this is an and statement, so we should have, anytime it's an and statement, very important, we're looking for the overlap. It's where they're both true, where we're greater than -4 and we're less than 2. So we're just going to draw both of them. So here's -4, open circle because there's no line, and we're going to the right. And then here is 2, open circle because no line, going to the left. And they overlap right here. So a lot of teachers like to either shade it or you just draw another line like that. That's our solution. This one's the same. This is actually the same thing as this one. This one's just separated. Like, that's all it is. If you really want to, you could rewrite it like this. 5 is less than k minus 2, and k minus 2 is less than 11. And then you could do the exact same way we just did this one. The exact same process. You just separate both of them. So 5 is less than k minus 2, and then you also have k minus 2 is less than 11. I like to solve it in one go. And the trick is, whatever you do to one side, you got to do it all 3 sides. And we're going to start from this middle here. So I want to get the variable by itself, so we want to add the 2. So we go plus 2, plus 2, plus 2. So we get 7 is less than k is less than 13. And I actually like to, for me, this is graphing, it's easier. You go, okay, where's 7? Up here, right there. Open circle. 13's over here somewhere off the grid. And then k is between those two. So your line's between the two. And there you go. That's how you graph it. So the key thing is you're working inside. Whatever you do to one side, you got to do it all 3 sides. You know, like 2 equations at once. Again, if you really want to, you can solve it this way. You just separated it. Separate the middle goes to both of them. That's the one trick. So if I was to solve this, would have been like plus 2, and you get 7 is less than k. Now remember, you do want to write it in proper form. So k is greater than 7. So we have line from 7 going this way. Then if you would have solved this one, plus 2, you get k is less than 13. So we would have started at 13 and have a line going this way, and they overlap right here. So either way, you get the same answer. So I guess we have more of these. So I'm just going to do plus 2, plus 2, plus 2. I get -3 is less than x is less than 5. So again, all we're going to do is, here's -3, here is 5, and then we're between those two. So that's our answer. This one I do the other way just to show you the opposite way. So again, you could do another way. You could do these two. -4 is less than 3x plus 2. And then you could do these two. And 3x plus 2 is less than or equal to 11. Again, this showing you so you can see another way of doing it. If I was to solve this one, I want to get x by itself. So let's subtract the 2 from both sides. I get -6 is less than 3x. Divide by 3. Remember, we're dividing by a positive, so nothing switches. You get -2 is less than x. I do want proper notation, so I'm going to flip it. X is greater than -2. So here's -2, close circle, and we want to be greater than it to the right. To the right. Kind of follow the arrow if you're not sure. Over here, for solving this one, minus 2, 3x is less than or equal to 9. Then we divide by 3. X is less than or equal to 3. So 3 is right here. Close circle, we're going to go to the left. Again, we're looking for the overlap because it is an AND statement, so the overlap is right here. Or you could just go, we're going from -2 to 3. So again, two ways to do it. Either do the same thing to everything, or you separate to two separate equations, whatever you like. I'm going to keep on going to my preferred way, which I'm going to just do the same thing to all three. So like here's my lines. I want to get the x by itself, so we got to get rid of that plus that -3, so we're going to add 3 to both sides. Whatever I do to one side, I can do it to all sides. And I get 4 is less than 2x is less than 12. Now we have to divide everything by 2. So 2 is less than x is less than 6. So we're going to go from 2, open circle, to 6, open circle, and you'll be between those two. So like that. Okay, next one, we're just going to do the same thing. I'm going to do the same thing to all sides. Let's get that x by itself. So I got to get rid of 2 first, plus 2, plus 2, plus 2. -8 is less than or equal to 4x is less than or equal to 8. Then we got to get rid of that x, so let's divide by 4. Get rid of that 4, so let's divide by 4. And remember, whatever you do once I do all sides. Notice we're dividing by positive, something changes, all the signs stay the same. So it'll be -2 is less than x is less than 2. All the inequalities stay the same. And there's our answer. We go from -2, close circle, to 2, close circle, and then our x is between it. So like that. So there's our answer. Let's do this next one here. So again, we're going to solve for x. Let's get rid of the 1. So whatever we do one side, I'm do all sides. So -1, -1, -1. I get -3 is less than x over 2 is less than 3. Gotta get rid of the 1/2. Opposite of dividing by 2 is multiplying by 2. So we're going to multiply everything by 2. And again, I'm multiplying by +2, so none of the inequalities are going to change. They're all going to stay the same. So -6 is still less than x is still less than 6. So -6 open circle, 6 open circle, and we are between those two. So your answer to be between those two values. Let's go to this one. Even like this, I'm going to do the same thing. If you want, you could distribute. I'm just going to divide everything by 3 first. Again, we're dividing by positives, so none of the equalities are going to switch. They're all going to stay the same. Like that. And then we're going to add 1 to both sides. All sides, I should say. And again, if you prefer, you could just rewrite it all. Oops. That is 4. You could just rewrite it, like put these two, put these like we did earlier. I like it this way. So there's our answer. Now in this case, we are less than or equal to -1. So that's a closed circle, but we are less than 4, so open circle between those two. Like that. Okay, how about ORs? Honestly, probably even easier. You just two separate problems at the same time. So let's do this one. -3, -3. 2x is less than -8. And then we divide by 2, x is less than -4. Over here, we're subtract 3 from both sides. That's our line. So you get 2x is greater than 6, and then we divide by 2. So x is greater than 3. So against OR statements, they're allowed to go opposite directions. So in this case, we have x is greater than 3 right there, open circle that way. And we have x is less than -4, so -4 goes that way. And there we go. That's our answer. It could be either less than -4, it could be greater than 3. Remember, if you're not sure the arrows, if you have proper notation, they just kind of tell you that's going to the left, that's going to the right. Over here, I'm going to solve each one separately. Here's my line. So let's go +4, +4. X is less than or equal to -2, +4, +4. X is greater than or equal to 5. So we have -2, close circle less than or equal to. And we have 5 over there, close circle greater than. There you go. So over here, same concept. +1, +1. Oh, it's going to be a fraction. No, it's not. Sorry. We get -9, and then we divide by 3. So x is divided by x is less than -3. And over here, +1, +1, 3x is greater than 9, divided by 3, x is greater than 3. So we have 3 that way, and -3 this way. There we go. So over here, let's solve this one. We're going to subtract 5, -2x is less than -4. Over here, -5, -5. -2x is greater than 4. Then we're going to solve each one. So I'm going to divide this by -2. Now here, this time we're actually dividing by negative. So we have to flip the inequality. So x is greater than 2. And the same thing over here. we're divided by -2, so we have to actually flip the inequality. So x, change this to less than -2. And then let's graph it. So we have 2 open circle that way, and then -2 open circle this way. And there we go. Again, this works for an or statement. If this was an and statement, it would be no solution. But or, this works. Okay, let's try drawing if they give us in words. So a couple of key things to remember. At least, or at most, right? At least is greater than. If I want at least 2 cookies, 2 is the low end. So you want to be greater than 2. Greater than or equal to 2. I should put with the line. At most means like I can't have any more. No, at most 4 cookies. So that should less than equal to. Then we have between and in between, and these are all inclusive. So that you use this. If you use either, that's an or statement. And greater than or less than, no, it's just, there's no equal to. You do a strike less than greater than sign. That's all that's about. So over here, all real numbers are less than -3 or greater than or equal to 5. So we want less than -3. So we're going to go less than -3 like that. And we want greater than or equal to 5. So x is greater than or equal to 5. So like that. I'm just going to draw those. Here's 5, open, close circle that way. Here's -3, open circle this way. Over here, a cake must be baked between 25 and 30 minutes, inclusive. So inclusive means we're going to include the lines. So we have x is between 30 and 25, and we want to include the lines because it's inclusive. I'm going to use t for time. So instead of my x, I should use t. And we're going to graph it. This number line does not work, so I'm just going to draw it. 25, 30, and then we are between those 2 close circles. So there we go. A quantity x is at least 10 and at most 20. So we're at least 10. So at least 10, greater than or equal to 10, and at most 20. So x is less than or equal to 20. If you think about it in the number line, the most you could go, man, this number line is not working also, I'm sorry. The most we could go is 20, and the smallest we could go is 10. Or it's going to be between those 2. So like that. The quantity is either less than 10 or greater than 20. So it's an or. Either is like or. So we could either be less than 10, or we could be greater than 20. As always, that's not working right now, so it's going to go 10, I'm going to go 20, and we could be less than it, or we can be greater than it, like that. So that's how you go from words to writing it. Let's do some real-world applications. A healthy resting heart rate for a teenager is between 1600 beats per minute, inclusive. Write a compound inequality for a healthy heart rate. So we're just going to be x is between 100 and 60, and there we go. A rectangle is the width of 5, and an area A satisfies 25. The A is between 25 and 30. Find the possible values of x. So area is length times width, like that. And we know this, we have a width of 5 and a length of x. So we have x times 5. And the way we're going to do this is, that's what area is. We're going to plug it in for the A right there. So we want to write an equation. So we know area, length times width, is just 5 times x. So that's our formula for area. So we're going to substitute it in for the A right there. So we should have something like this. 25 is less than 5x is less than 35. And then we're just going to divide everything by 5. We're going to get 5 is between x and between 7. Or, if you want to draw it, 5 and 7, either anything in between those 2. That's what the length is. Anything in between those 2. Okay, look about their knowledge questions. As soon as solved, -3 is less than 2x plus 1 is less than 9 by only working with the right side, 2x plus 9. Giving x is less than 4. They wrote the final answer, x is less than 4. Explain what part of the problem they ignored and gives a complete correct solution. Well, they ignored the left side, right? They only did the right side. So they totally forgot about this guy. Then we're going to subtract 1 from both sides. We get -4 is less than or equal to 2x divided by 2. We have this -2 is less than or equal to x, which I want to rewrite as x is greater than or equal to -2. Or, since we have this part of the answer, let's combine it. So x is going to be, combined with this guy, between 4 and greater than -2. That's a full, complete answer. Right, explain what part of the problem they ignored. They ignored the lower bound is probably the best way to say it. They ignored the lower bound. They only worried about the top lowered bound. Okay, last one. Explain why the compound inequality x is greater than 2 and x is less than 2 and x is greater than 8 has no solution. while x is greater than 2 or x is greater than 8 has infinitely many solutions. Use a specific number line to answer your question. So for the first one, x is less than 2 and x is greater than 8. If we draw a number line, here's 2, here's 8. Notice with an and, we need an overlap. That's where they're both true. So we're missing overlaps. That's why it's no solution. No overlap. They don't have a place where they're both true, so there's no and. That's how and works. Over here, we have x is less than 2 or x is greater than 8. This one doesn't have infinitely many solutions. I don't know what they're talking about. Well, I guess kind of. An or doesn't care. You could be greater than 8 or you could be less than 2. It works. So I'm not sure what they mean by, I guess there's kind of infinitely many solutions by the looks of it, but there's no, but this is not an answer right here. Like, you can't be an answer between -2 and 8, so it actually might be a little bit wrong. I gotta recheck this question. But with the NOR statement, that same thing doesn't hold. You could be less than something or greater than something. That works. You could be outside the house, you could be or inside the house. That doesn't work. You can't be both inside and outside the house. Like, that doesn't make any sense. So or is a different, it's English, different phrase. So it means something differently. Anyway, that's the idea. And you need an overlap, or you don't need an overlap, just wherever anything is. And that's the worksheet.